Hey guys, so today we're going to be talking about adding mixed numbers, and we're going to use two different problems in order to do this. And I have my trusty dusty sidekick right here with me. Easy, easy. You guys to get down. He likes to make videos with me too. Say hello to everybody. Can you say hello to this computer? Say, oh hi everybody. Say hello. Alright, so we are going to start today with our first problem. And our first problem is going to be 6 1/4 plus 5 2/3. And we are using the four-square model in order to do this. When we look at this problem, in the first box, you're always just going to see the problem written out. 6 1/4 plus 5 2/3. In the second box, we have to find the least common denominator. At this point, you guys should know that that means that you have to list the multiples of each of those numbers. So I've got my denominators 4 and 3 written out, and the first thing that I need to do is I need to list the multiples of them. If I look at the number 4, by this point, again, multiples are the numbers that you count by. So when I count by 4s, and I'm always going to list my first 5, I get 4, 8, 12, 16, and 20. Now I know if I don't find a least common denominator within those 5, I'm going to have to list more, but I think I'm going to be able to find a common denominator within those first 5. For 3, I have 3, 6, 9, 12, and 15. So now I have to look and compare. Do these two numbers have anything in common? And when I'm looking for in common, I'm looking for the smallest number possible. So I look, and they both have a 12 listed there. So 12 is going to be my LCD for this problem. Now, in the third box, this is where I change my fractions. I can go ahead and write that 12 there in that box. But I've got to do some multiplying in order to find those equivalent fractions that have the denominator of 12. So, for 6 1/4, 4 times something equals 12. And if I look back up here, I notice that 1, 2, 3, 12 is the third multiple. So that's what I'm going to have to multiply by here in order to find an equivalent fraction. Whatever I multiply the denominator by, I also have to multiply the numerator by. I'm multiplying by a fraction that's equivalent to 1. Hopefully you're making that connection. 1 times 3 is 3. So 6 1/4 is equivalent to 6 3/12. 3 times something equals 12. If I look back up here, 1, 2, 3, 4, 12 is the fourth multiple. So I multiply by 4 fourths here. Again, what I do to the bottom has to be the same as that I do to the top. 2 times 4 is 8. So now I have the problem 6 3/12 plus 5 8/12. And when I go to set up my problems in the fourth box to solve, I like to break them up so that way I know what I'm adding. You're always going to add fractions together, and then you're always going to add whole numbers together. So when I look at my fractions, remember we only add numerators. 3 plus 8. 3 plus 8 is 11. I keep my denominator the same, which is 12. And then 6 plus 5 is 11. So that gives me a final answer there of 11 11/12. Alright, for the next problem we're going to look at, this problem is 2 4/5 plus 1 1/4. So we're continuing to add mixed numbers, and we're continuing to do this with our four-square method. Because we have one of the same denominators as the last time, which is 4, I just kept our multiples from the last time because we've already listed out the first 5 multiples of 4. What we have to do this time, though, is list out the first 5 multiples of 5. And again, we're just counting by 5s when we do that. So 5, 10, 15, 20, 25. Now we look to see if they have anything in common. And when I look at this one, I notice that the number that they both have in common that's the smallest is 20. So my LCD here is going to be 20, and in the third box, I can go ahead and write that in. Now all I have to do is figure out what I'm multiplying by. So for my 5 times something equals 20. Well, it's 5 times 4. So I multiply by 4/4. 4 times 4 is 16. So 2 4/5 is equivalent to 2 16/20. For my second fraction, 1 1/4, 4 times something equals 20. Well, I know that that's 5. So I multiply by 5/5. 1 times 5 is 5. So 1 1/4 is equivalent to 1 5/20. Now I'm going to rewrite these fractions. So 2 16/20 plus 1 5/20. When I go to solve this problem here, okay, again, I'm going to break it up into my whole numbers and my fractions, and I'm going to start with my fractions first. So 16/20 plus 5/20 is 21/20, and 2 plus 1 is 3. Now, hopefully you're noticing something that's wrong with this problem, because if I look here, I notice that my fraction right here, 21/20, is an improper fraction. Well, I can't leave my answer like that. I have to change the improper fraction to a mixed number, okay? So when I go to do this, I'm going to do it just like we've done it in class. 21's going to go in the house, 20's going to go on the outside. How many times can 20 go into 21? It can go in there one time. 1 times 20 is 20. When I subtract, I'm going to get 1. Now I need to form a mixed number from this. This is my whole number. 1, or my leftover, is my numerator, and my denominator, 20, stays the same. So I have the mixed number 1 1/20. But that's not my final answer, because I cannot forget about the 3 that I have right here. So my final answer is going to be found by adding 3 plus 1 1/20, which we've already talked about earlier this year. We talked about adding your two whole numbers, 3 plus 1, and getting 4, and then just moving that fraction over. So for my final answer here to this problem, I have 4 1/20. As always, if you have questions, please make sure to ask your math teacher, and just let